40 seconds.
No, because the recording starts exactly.
I think you can just
Pardon?
Okay.
Okay, so this is something experimental.
Yeah, that's sort of a talk. It's not really a talk.
Yeah, it's not really a talk, it's a thing.
Yeah. Yeah. But anyway, welcome everyone. Thank you for attending this thing. My name is Antoine Jacotot. I've been an OpenBSD developer for 11 years or so. And yeah, I think that pretty much sums it all.
I'm Baptiste Daroussin, I'm a FreeBSD developer, member of the core team, and I'm in the project since almost 8 years now. And we're here to speak about things.
Yeah. So just a quick disclaimer before we start. We're going to talk about a lot of different topics. But of course, first, we're not expert at everything. And second, each topic that we're going to talk about could have their own 1 hour talk. So there are a lot of stuff we're not going to go deep into. So sorry about that. And well, first let's start with how we came up with the idea of this talk. Because it was pretty funny actually. It was like, I don't know, it was summertime, it was the afternoon, we were having herbal teas, sponge cake, something like that. Oh.
Yeah, exactly. We were having interactions, talking about something like the ponies, unicorns, where the first stars.
Yeah. Who came first, blah, blah,
Yeah.
blah. Yeah, that
The
was
usual
it.
the usual meeting you can have.
Yeah, exactly. We
Yeah.
have a lot of philosophical discussion with Baptiste. And
Yeah.
so that was it. So quite summer afternoon. And
Well, no, you can tell them.
yeah, okay. We'll make it in. It was like 2 a.m. It was in a pub somewhere. I don't remember where. We were having our 10th pint of, what was it, like crappy beer, like I don't know, like Duvel or something? Or...
Yeah, no, you can't say that. We're in Belgium.
Oh, right, sorry. So it was, what was it?
Oh, it was crappy beer, it was Heineken.
Heineken, sorry. So we're having our 10 pints of Heineken, and I was like, oh, Baptiste, this beer that doesn't have any flavor anymore. It's like, I can't feel the taste. Yeah, and that's when it hit me. My God, you guys, you suck. You don't have flavor packages.
Let's get ready to rumble!
So, talking about flavor. Flavor in packages on OpenBSD is actually a very interesting concept. I'm not aware of any other Unix package manager that actually implement it. That doesn't mean there aren't, it shows that I don't know any. What a flavored package does is that it allows you to provide packages compiled with a different set of options. So that's very convenient from a dependency point of view. Since according to the options that you want to compile the package with, the final binary will change, since it will end up linking to different libraries, etc. So to give you an example, let's say you want to compile SendMail, and you want to give it support for SASL or LDAP, anything like that. So of course, if you compile against LDAP, your package will link against LDAP. Maybe it's something you want, maybe it's something you don't want. And the thing is that on OpenBSD, we really want the user to use packages and not compile things. So Flavor lets you basically create a package with a predefined set of options. So we actually have several assignment packages that you can choose from when you install it, that they all conflict with each other, of course. And that's actually pretty convenient from a dependency point of view. It's different from what a sub-package is. Sub-package is when you build one big package that's too split. So that's typically used for things like PHP, for example. On OpenBSD, we build PHP with support for all modules. And at the end of the packaging, we actually split the package so you have PHP IMAP, PHP MySQL, PHP blah, 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 stuff like that.
Yeah, on FreeBSD, it's true that we don't have the flavors. Actually, we have kind of, I would say, shitty sub-package system where you just hack things so that you get actually a sub-package. So for the case of PHP, it's basically the same as OpenBSD, and then you get PHP-IMAP, whatever. But it's true that some situation like for LibLDAP, where you probably want to enable or disable SASLs depending on what you need. Right now we have two packages, they both conflict together, but imagine someone is depending on LDAP and doesn't care if it's SASL or not. What we have defined as the default is the default. So if you install, I don't know, libLDAP SASL and some mail depend on libLDAP, then it will remove some mail, which is probably a good idea to remove some mail anyway. But but we have work in progress in that direction. We are working a lot on that. The problem is we have a lot of old tools that deals with the port tree, port master, port upgrade, and stuff like that. That depends on having a unique origin per package. And if you go to flavors, if you go to sub-packages, then you break that paradigm. So that's why it took so long to come now. But we have decided that, okay, fuck those tools. Let's make this happen, and if someone cares about those tools, they will have to fix it. And we'll be happy to keep those tools if it's fixed.
Okay, so like let's say I need SASL support in OpenLDAP on FreeBSD.
Yeah.
So I assume I need to build it myself, right?
No, actually we have a package for it.
Oh, okay. But then what happens if I run like package update and package upgrade?
It will remove everything that depends on your LDAP.
So that's nice.
Yeah. Yeah, so one of the things we do support, and I don't know what to do, is we do support upgrading packages on a given release. I mean binary. I got security issue, I got a new version, and I update packages in place.
We actually do support binary package upgrade on a given release, but we do not provide the precompiled packages. So so yeah, it's true that you need some kind of a build box where you can distribute your packages update from. There's actually work in progress in this area, and I'm pretty confident that within this year we'll be able to provide binary upgrade for packages on all our supported releases.
Oh, nice.
Yeah, so keeping your box up to date will just be a matter of package add minus u and update. Talking about distributing packages, actually, it's important to note that there are a lot of operation on OpenBSD when using package add are all done in using a non-privileged user. The fetching the packages, extracting, verifying the signature, etc. is all done as a separate user. We don't go online as a root or nor as the build user. We actually prevent the build user to go online. And if I remember correctly, you guys tried to do that in libfetch, dropping privilege, something like that. That was reverted.
Well, actually, yeah. What we do is since day one, almost. Well, since capsicum's day one, the package is capsicumized. So every single dangerous area are running in the sandbox. We also added some privilege drop recently. Actually, just before you did, in a few weeks before. Well, actually, it's 3 days exactly. I checked. Before when BSD did, I had to revert the fetching part because it wasn't able to read the .NET-RC something that people were using.
Oh,
so for the next release, I will add it again and add a mechanism so that I can fit this .NET-RC file. But anyway, we are sandbox almost everywhere, so we're safe even if we root. But of course, it's better to have privilege separation. And most things in package now, if they don't need root requirement, switch into a non-privileged user.
Okay. Well, I guess we're pretty much done with the package side. Well, no, I just wanted to add that there is a big difference in the way we see things in OpenBSD and FreeBSD when we regard to packaging. Is that since day one, our primary goal was always to provide binary packages. So it is a little bit shameful that we're not actually providing upgrade for these packages on a given release. As I said, this is going to change. But it's really a different different vision that we have compared to you, where you actually do build a lot of stuff, or at least historically you used to build a lot of stuff. Thank you.
I'm a bit late. Yeah, we used to build a lot of stuff. Well, I'm lost.
Yeah.
Okay. Yeah, but one thing about the post tree, that it works on every single supported version of FreeBSD, because we have kind of long-term support in FreeBSD. And so it's hard to make large modifications that may break old version. But yeah, that's something you don't really know, as you do support only something for 6 months.
Well, you're correct that for packages we only support the current release, which today is 6.0. The OS itself is supported for 2 releases. And aside from current snapshots, our port tree is actually tagged to a specific release. So we don't follow a rolling release model on the port tree. And we don't want our user to be forced to upgrade to a new major release of the software on a given release. So if you have a major update of some port in your tree, maybe you don't want to have to be forced and update it until you actually upgrade your operating system as well. So it's against a different way of seeing the packaging, I guess. Also considering the fact that we do have regular 6-month releases, our packages don't have really time to get very old anyway. So I don't really see it as a problem, personally. But that's, as I mentioned, there's an ongoing discussion about supporting previous releases, not just the current one. And yeah, that's it. When I say support, what I mean is that we actually provide a CVF patch, FOSDEM, and for the package, we're not providing the binary packages, but for base, we're only providing diff as well. We're not providing any binary update or whatever. This is actually going to change. There is a little work in progress tool called syspatch that will allow you to patch a given release of OpenBSD without the need to recompile anything, which I guess will make a huge difference in the way people put OpenBSD in production. Other than that, yeah, I do understand the need for LTS release. I do, but I just don't want to be the one who actually administers those kind of releases. Talking about support, I see that you guys have like some long-term support, extended support, normal support. I mean, what the fuck is your policies? How come FreeBSD 10.1 was still supported and 10.2 wasn't?
Come on, that's easy.
No.
No. In our model, what we have the normal releases. So a normal release is a release you take out of the stable branch, you say, okay, this is FreeBSD 10.0, and then you support that for a minimum of 12 months. And so to quote the policy on the website, and for 2% additional time if needed to ensure that the newer release, that there is a newer release at least 3 months before the older normal release expires. So that's the normal one, easy. And then you got the extended. And so the extended is basically you select a release, usually the second release each time, and you keep it for 24 more months, and that's it. And also the latest release of a given branch is extended support, so you have 24 more months on the latest one, so that's easy.
It is?
No, really not. That's the reason why on FreeBSD 11 we've decided to change that to a model that everyone will understand.
Oh, okay.
So basically right now, a given branch, like say FreeBSD 11 will be supported for 5 years, and we can make release whenever we want out of that branch. As soon as the release is there, people will have, I don't remember, something like 3 months. They have 3 months to upgrade to the new release, and given we provide stable ABI, they're just, let's say, a newer revision of the same release, and then people can exactly know where they are and how long it's supported. And you won't have any more 11.1 supported while 11.2 is not supported anymore. And you can understand what you're doing.
Okay. Okay.
Yeah.
Well, it looks like the FreeBSD support model keeps newer feature out of the hands of the user. If I understand a bit what you mentioned about how releases are supported. In my opinion, I mean, our model makes a bit more sense, and it keeps the code stable but still pretty fresh. We have a new release every 6 months. Whatever is in current will be in the next release in a few weeks, or in worst case in 5-6 months. How does it work?
Yeah, well, I think you misunderstood the way we are developing. Like the FreeBSD 11 branches will not only receive bug fixes, but also new features as long as it don't break the ABI and compatibility. Let's say we have a new Clang version and we need a new Clang version for anything, so a new compiler. Then we can just merge the compiler, and 11.2 will be released with a new compiler. So all the new feature will end up anyway in the releases that the user have. So that's not that different. It's just that we do guarantee that we don't break the ABI. So if you build a binary on FreeBSD 11.0, then on 11.3 it will run out of box.
Okay. Well, you did say that you had to wait for at the very least 2 years before being able to use modern tool available.
Before, in the port 3. Why? Because with the previous model, we had to support a release, and we don't release a new version, because if you release a new version, let's say we release 10.4, then the support gets extended for 2 years, and then we can't bring new tools. So because the port 3 works on 11 and 10, then I need to get the compiler I got in my 10.4 working for the port 3 anyway, or the feature that I added, which are in FreeBSD 11 and not yet in 10, I would have to wait two years in the port 3 to be able to use them, which is not the case anymore, because with the new model, what I do is just merge that to 10, release a new version of 10, and then in that case, I don't extend the support, but still the user benefits from the new tool, and the port 3 can just straight away use it. So we fixed that with the new release model.
Okay. Anyone got it, or? I'm still a bit confused, but okay, trust you.
Yeah.
Okay, let's talk about binary updates.
Yeah. Let's look at binary updates. Okay. Given we support binary upgrade, it's very easy to upgrade from a minor version to a new minor version. Let's say I release FreeBSD 11.1, I just do FreeBSD update, FreeBSD upgrade, and I'm going to the new version in place, and that's very nice. But I'm also able to go from major release to another major release and do a nice upgrade. So it's very simple. It helps us to do a lot of things, and seriously, how tedious it should be for me to update OpenBSD boxes where you are breaking ABI, you can't upgrade in place, and
Well. I see what you're doing. Actually, it's not entirely true. As I mentioned earlier, binary upgrades between releases are perfectly supported, obviously. What is not supported, indeed, are in-place upgrades of the base system, at least. Well, I don't see it as an issue. Usually supporting in-place upgrade is nice when the actual upgrade process takes a long time, so that you don't want to have your machine like offline for like 30 minutes. But when you have machines in production, you have redundancy anyway, right? So I don't see it as a big issue. Also, the upgrade process of OpenBSD itself is one of the easiest and fastest that I've worked with. That's actually an objective review. It is. I mean, just reboot on the BSD RD, run this kernel, and it will do the rest for you in like 3 minutes, seriously. And with support for auto install and auto upgrade in OpenBSD, you really have absolutely nothing to do. It's completely automatic. I mean, you can upgrade like thousands of bucks and by just rebooting on the proper kernel. Everything will be automatically upgraded, packages included. And when you first boot after the upgrade. We have sysmerge, which is like a merge master tool in FreeBSD. Is run automatically very early during the boot process. So even your configuration file will have a good chance to be automatically updated. The thing is that if you tweak your configuration file a lot, then obviously it will require manual intervention. It will not try to force upgrade the file.
Yeah, it's a merge, I think so. It's complicated anyway.
Yeah, it's complicated, but it will send you a mail telling you that this and this and this file.
Well, if it boots.
There is no configuration file that will prevent you from booting.
Yeah, okay.
Because
It's
the
your mailer
tool,
works.
the tool is run after.
Yeah.
So don't try and trick me here.
Okay, so that's not that bad. So you're able to go from a release to a release. Seems that it's pretty okay. But what you do to update in your, I mean, you got security issues and let's say, yeah. You got security issues and you need to get a diff on your system. It's running. What do I have to do? Seriously, I take the patch, I apply it to CVS, and I build?
Yes.
Welcome
to the 80s. Well, yeah, I mentioned it a bit earlier as well. It's true that updates within a particular release are not supported. I mean, they are supported using a CVS patch. So you have to build a new release yourself. Or I mentioned syspatch earlier. Hopefully, it will be enabled for our next release, 6.1, in a couple of months. It will be a technological preview, meaning that the tool will be there, hopefully. The way it works may change for 6.2 or 6.3. We'll try and learn how people use it and the usage that they're doing with the tool. So what we did is that we tried to create something really stupid and simple, something that will just fetch precompiled tarball, same kind of tarball that we for the base system set. So fetching, verifying with Signify, extracting, and then installing the new binaries, libraries, etc., while creating a rollback tarball in case something bad happened or if you need to roll back a patch for whatever reason. So we're trying to have a very, very, very simple tool, and hopefully people will like it and it will become permanent.
Cool.
Yeah, hopefully.
Well, on FreeBSD, we do support right now already binary upgrade in place, which are very nice. I mean, you get security issued to the FreeBSD that fetch, FreeBSD that's installed, and then everything has been replaced, modified. So the way the tool works is basically it works based on binary diffs. So security officer will just rebuild the system, make a binary diff of the binaries that has changed between the two builds, and then you fetch it and you install it. It works very nicely. It's very convenient for security fixes. It's very simple for the user. It's safe. FreeBSD update does a bit more things, like I said earlier, upgrading from a release to a release. So the way it does is, well, the same way you do fetch. You fetch all your new binaries, well, actually patches between the old release and the new release. And then it's install the new, well, patch your kernel and prepare the kernel. You reboot on the new kernel. You're on the old userland, but the new kernel. Then you install the new userland. That's to prevent having new userland that might have syscall that doesn't exist yet in your old kernel. And then it merges all the configuration file, and hopefully everything works. This is nice. It works fairly well. The problem is it can be very long. I mean, by very long is try to fetch something like 100,000 of binary patches until they get it. And then try to wait for your shell script to figure out which one it should patch, how it verifies checksum, signatures, blah, blah, blah. So it can take a very long time to be able to upgrade from a release to another one. So we are now trying to experiment with replacing that package itself. So if we package the base system, so it will remain the base system but split into multiple packages, then it depends. I don't know yet, to be honest, but a lot. And And then when you get security update, you get a new version of your package, and then your package upgrade. It's installed like every single thing we have in the port 3 on the packages already. And that might be way faster than what we have right now. One of the issues, to be honest, with there is some drawback with in-place upgrades, is we depend on some technologies that we don't develop initially ourselves, or we depend on another upstream which we work with, like ZFS. And that upstream decide, well, for them, the upgrades are a bit like on OpenBSD. Like you get a release and upgrade is try to go to the new release. And so the kernel and the user has to be the same and in sync. While on FreeBSD, there is a moment you are on a new kernel and you still have the old user tool. And if, let's say, some function from ZFS has changed, then your user tool won't work with that. And we had a couple of times to re-implement the backward compatibility into ZFS to make sure that we can support our ZFS upgrade. So it's extra work sometimes. But I think it's worth the price.
Okay, well, do try to be very, very clever here. We're way much simpler than that. But anyway, yeah, well, in place of grade, yeah, okay, that's nice, but you still need to reboot. I mean, if you had in place of grade that you don't need to reboot, then yeah, okay, you'll have my vote. But other than that, I don't really see the point.
Yeah. Well, anyway, another interesting thing we have in the FreeBSD model is what we call POLA. It's principle of least astonishment. So basically, it means that don't try to fuck up the user system. So if something was working, you upgrade to something new, make sure that you don't break everything on the system and that your upgrade goes out of box.
Yeah, and you know, we're not afraid of breaking backward compatibility when we think it makes sense and can help us push ideas forward. But that's it. I can understand the need for POLA, obviously, except when it goes against basic security. Like, for example, reading your upgrading file somewhere in the source tree, I think SSH or something. I see that just to satisfy third-party clients, you guys kept DSA encryption, AES, CBC, SSH1 support, like month and month after upstream actually removed it.
Yeah, because on the release, we didn't want the guy to be able to upgrade and having their key not working, but on the next major release, we removed that. So yeah, given our model, it's months later, for sure. But that's not exactly also what POLA does not really prevent every such thing. We could have removed that if we wanted. That's the drawback of POLA. People, if they don't like to do something, they scream at POLA and say, hey, don't touch my system. While POLA says, we should not fuck up the system of the user, but sometimes we need to, and so we need to tell them how they will have to upgrade and have warning long enough in advance and things like that. So yeah, we have to be very careful about POLA. It's a very nice principle. It's just not an excuse to not do anything.
Yeah, yeah. Okay. Speaking of upgrade delivery, it would be interesting to know how you guys build and ship packages. On OpenBSD, we use a tool. It's called the DPB, the Distributed Package Builder. It's a Perl daemon that orchestrates a multi-node setup for building the entire port tree or a handful of set of packages. It allows us to build like the entire set of packages in less than 24 hours, which is convenient. So we can have a new set every day. As most of our daemon, it comes with privilege separation. It runs at a different build user, as I mentioned earlier. It uses a short sandbox to build packages. The actual goal for that would be like each package build will have its own sandbox. So there's work in progress for that. And yeah, as I mentioned, the only process that goes online is the fetching the TS5 log.
Well, on FreeBSD, historically, we were using a tool which had a design, besides being the total crap, had a design which was pretty close to DPB. It was called Tinderbox. And it works quite okay back in the time, but we changed that to a new tool, which actually I wrote.
Stop showing off.
Yeah. It's crap as well. It's my code. And so basically what it does, instead of distributing the build, which can bring a lot of complexity to always do I still communicate with that box, blah, blah, blah. We decided to build everything in one single box, distributing one build per core. So we ended up with something like if you have a 24 core box, you have 24 packages that are built at the same time. And doing that, by surprise, we discovered that we got faster builds. We ended up with something like a single day to build the entire port 3 back in the time when it was only 24,000 packages. Now it's way more, and now Chrome exists. And so aside from that, what we have is the packages are signed on a box without internet access. The main difference with the way you are doing is probably because we don't sign per package. We sign the entire repository, which has hashes of what package is, so we have only one signature to check instead of checking per package.
Yeah, that's a difference. We don't want to rely on the repository metadata for anything. So indeed, we do sign each and every package, which make them also easier to share. Yeah.
Yeah, so since we switched to Poudriere, we're now able to provide updates and binary packages almost every day, while before it was whenever that cluster was happy to build things and to build things properly. So while working on that, that new tool to have a lot of, to have faster builds, whatever, we use every single functionality that we have on FreeBSD, like we use jails to separate the builds to make sure that they don't have access to the network when they don't need access to the network. We can use ZFS to have a fast population of the various jails, so each build in a single jail on a single core. We use TMPFS if we want fast I/O. And of course, we do use SMP because, yeah, we can run on more than 24 cores. Oh, speaking of multiple cores, are you guys still having the giant log somewhere? Well, everywhere?
Yes, we do. Okay, there's work in progress, obviously, but honestly, for regular desktop usage or big log SMP implementation model, so the kernel log, is good enough. The reason is that most time on the workstation, you only have a handful amount of cores, between 2 and 8, and only one socket. And our actual scheduler isn't bad either. It's just that it's a bit old. It was written for real SMP machines, meaning that it does not consider the cache distance between the cores. And that's one of the main reasons why the machine with several sockets often have lower performance than the one with only one socket. It's true that we do a lot of ping pong. So we can use 24 cores. But in the context of bug build, it's way, way better for us in terms of performance to actually split these 24 cores into 6 different machines. But hopefully performance will improve.
Yeah, well, I wonder how you will handle this kind of change in the model of OpenBSD. Because, I mean, when FreeBSD took that road and changed the model to go to something more SMP, it took a lot of time. It also ended up with some fabulous release like FreeBSD 5.0. Yeah. And so I'm not saying that the road we took, well, we have to change almost everything in one big release. Is the only one to go, but I don't see how you can do with a very incremental, simple way, getting rid of this giant log.
Okay, well, there's a few things that can be incremental because they're not completely related to the scheduler itself. Like, for example, some performance issue that we have on OpenBSD actually come from spin lock in our pthread implementation. So that's being actively worked on. We do expect a huge improvement in that regard for the next release or the one after. And contrary to the myth, I mean, we scale very nicely on the big userland workloads. Of course, is our raw performance on par with FreeBSDs? No, but we have different priorities. And we're okay if we lose a bit of performance, if that gains us more security or more simplicity or something that's closer to the goal that we have.
Yeah, so to tell the truth, anyway, SMP support is something that should be done all the time because things changes. You go from one socket to multiple cores and whatever. And on FreeBSD, the next challenge is really to get something like better NUMA-aware support in the kernel. We need also to improve a lot of locking mechanism to get into, if we can, direction of lockless things. So we are experimenting right now with concurrency in the kernel. What is the current status right now of your moving to a fast SMP on OpenBSD?
Well, our entire SCSI stack and kernel profiling are already fully SMP, for example. Recently, there's been some huge work and progress on making our network stack SMP friendly. The goal being to be able to forward traffic over multiple threads and things like that. I don't think you will argue the fact that modern scheduling is hard, as you mentioned it. Most operating systems actually had to do it several times. I mean,
Yeah.
some even rolled back, and I mean, when you see what happened in the Linux land, for example, it's completely scheduling, right? I mean, they have like 10 different scheduler, and so yeah, that scaling is hard. So as usual on OpenBSD, we lag a bit behind in that regard, but we're also learning from the other operating system mistakes. So hopefully we'll come there slowly, but and hopefully with a simple implementation, because that's how we like things. When, as I said earlier, you guys are way too clever. We're just
Right, so while you're here, can you explain me something I never understand on OpenBSD and the way you handle the project? It seems like you keep rewriting all the tools, even if there is already BSD license counterparts. I mean, HTTPD, SNTPD, VMM. Well, you're not suffering some kind of NIH syndrome?
That's actually a very good question. I'm glad that you ask it, because in my opinion, there are very objective reasons to do that. The first one would be trust and control. We have a coding style, practice, and process that makes us confident in what we develop. We know someone will not decide to change the software license, for example, one day to the next, or start adding options and knobs for each and every crazy corner case that no one would be using. And looking at how many CVEs impacted like NTPD or OpenSSL in the last couple of years should be a good hint as to why it was necessary to actually create NTPD implementation for us, or fork and become LibreSSL. So I don't think it's really an NIH syndrome to want to write secure implementation, even if a BSD counterpart does exist.
Right, but let's there's no BSD quality good enough, well, but not good enough in BSD alternatives. But what about Beehive? I mean, it was working because of the design. It's very easy to add security requirements that you may want. And so why started a new implementation?
Well, because we had to, basically. A few years ago, an effort was started to actually port Beehive. But after just a week trying to do that and not even being able to compile like 2 C files, we decided that, I mean, if it's that much work to port this software, then we just should write our own from scratch. I mean, the situation may have changed since now Beehive has been ported to macOS, I think.
Yeah.
Yeah. So maybe it evolved, but at the time it was really complicated. But there was an effort that started. So it's not that we said, okay, let's create VMM and not look into Beehive. We actually did look into Beehive. So, but on and on, I guess having control and rewriting some part of the software ecosystem gives us a base system that in our definition just works, and works the way we want it to work. Like you ever feel the need to tune or harden something on OpenBSD or tweak or build billions of options, then you're clearly on the wrong operating system. And that's why also we're rewriting things to be really simple.
Right, right. But I mean, what about the case of sandboxing? We have Capsicum. It works. It was there way before OpenBSD. So why not?
There's also a very good reason for that. But before we talk about Capsicum and our sandboxing implementation, since you brought up the subject of security, we can talk about it a bit.
Okay, let's go on it. So I maybe start with something which is not directly related to security, but helps a lot when you develop to get secure application, well, to not get flows. So let's talk a bit about our malloc implementation, which is the gmalloc. Yeah, so that tool is very nice. Well, that malloc is very nice because it helps us to, you have a lot of tuning you can do on it through malloc.conf or the malloc.conf variable, where you can, for example, use a tool called profleak, which allows you through malloc to detect memory leaks, a bit like dbuf tools are doing that. We can do heap profiling. We can do a lot of things like that. We can also put some garbage in the memory when you malloc so that to make sure that you don't corrupt things.
Yeah, I think we're pretty similar in that regard. Our memory allocator has a lot of countermeasures as well. Some are not enabled by default because they're very costly in terms of performance. But we, developers, do run with them because it allows us to catch a lot of different issues beforehand. So they're pretty. We have a lot of very convenient options in our malloc. The capital C option is a good example. It enables all the security-related options in malloc for security auditing. We have quart pages that can be enabled, so just to provide you with overrun detection. A whole bunch of different countermeasures like that.
Yes, like both malloc are quite in the same chain regarding debugging and memory-related potential security issues, but in a different way,
Right.
almost the same.
On a side topic, related but different from malloc, the way we develop our daemons on OpenBSD are always pretty much the same. We do privilege separation. Most of the code is one-shooted as a non-privileged user. And OpenSSH kind of led the way for the way we're doing things now. It was the first to actually implement all of this before anything else in OpenBSD. So we use also privilege revocation to drop privilege as soon as possible. I mentioned NTPD earlier, which is a good example. It's a really traditional, if you look at the code, it's a good example because it's a traditional OpenBSD written daemon. It was written with principle of the least privilege in mind. So not only does quick set and quick drop, but it also has complete privilege separation, TLS speaker for the constraint feature. The constraint feature is actually a pretty cool one. It allows you to mitigate the man-in-the-middle attack. Basically, when you ask the time from a remote time server, you will also connect using HTTPS to a well-known website, Google, Apple, whatever, and get the time from the web server as well. So you can actually compare what the time server and what a well-known web server on the internet gives you. And if the constraint is too large, then there's probably a problem somewhere.
Yeah, the thing is, you did that, but that have a lot of problems in the case of NTP. Like, for example, you don't support half of the features that are supposed to be supported, like authenticating the peers, which are giving you as a time, or supporting proper lexicon in that case.
Yeah, but you actually just described exactly the strength of OpenFTPD. It is simple. It doesn't need to authenticate because we use constraints. That's good enough. It doesn't need to implement the kitchen sink because no one cares and no one uses most NTPD feature. And if there is a need for it, then we have the NTPD package that people can install and use instead. It's just by default we want something simple and secure. And on a related topic, we are well known for our numerous exploit mitigation techniques. it's important to note that all of these have been enabled by default for years, and they're very hard to actually disable. We don't want to encourage people to activate them. We actually activate them by default and make it very hard to disable them. I won't go into a lot of details, but we have ASLR, or no PAX people here, I can say ASLR. WXRX, the stack machine protection from Propolis, Pi executable for static binaries as well. The way we approach the OS development is that we assume that we're running in a hostile environment. So everything we do is actually depend on that.
Yeah, so in FreeBSD, well, yeah, we don't have yet SLR, but we have probably also we have a couple of mitigation technique, way less, I agree. But we also have something like the primary, which is mandatory access control, which is very nice to be able to compartmentalize what an application is supposed to access to as a resource, network, file systems, or to view on a system, preventing seeing that there are other users, other process, and way more. We also have a very nice auditing framework through OpenBSM, which allows you to let's report everything that happened on your system, and even report that on a remote machine if you need to through a distributed mechanism.
Okay. Well, just to rebound on what you said earlier regarding Capsicum. So we do have a sandbox implementation. It's called Pledge. So now the reason why we did not port Capsicum is that Capsicum is too complicated. I'm not saying it's bad. It's a very good capability system. It's just too complex. And as such, we think it doesn't get as much use as it should be. The Pledge Cisco is actually very simple and describe exactly how we envision security. We want to provide affordable security. By affordable, I mean simple, easy to use, and make it easy for the actual developer or programmer to add Pledge call into his code. When Pledge was implemented, 30% of our base system was pledged after only about 2 months. And today, we have between 85 and 90% of the entire userland in base that use Pledge. And even some big ports like Chromium is pledged. So it's actually pretty easy to use, and as such, people actually use them. It also has a nice side effect is that I guess that's also true with Capsicum, but it encourages actually re-auditing your code to know exactly where you're going to put the pledge code and things like that. So yeah.
Another feature we have on FreeBSD that you don't have is the jails, which are container secured by design, by default, and which allows you to run the process in a prison that cannot do anything if you want to, like reducing, you can just limiting the number of CPU, you can limiting the memory, the resource, the access to the network or no, and things like that. That is very powerful to be able to add security on the system.
Yeah. In that regard, I do agree that we suck. We have no container-like technology. There's been an initial effort a few years ago called sysjail, but it was using systrace, which had a big security flow that rendered basically the sandbox completely new. So, but anyway, let's.
Well, I think given the time, we'll probably skip the project explanation on how the different project works, and that's a round 2, which will last for only a few minutes, so sorry.
Well, it's a 2-track. So.
Yeah, it's supposed to be a 2-track though, but... Right, so let's speak about the BSDification. I mean, you claim a lot about your license purity, everything should be BSD, and we do almost the same, but I'm very surprised by the fact that there's a lot of projects we're working on to bring BSD license tools in the base system, and we don't see you in that area. In particular, when we speak about the toolchain, for example, we're very close to get the first release without GPL in base in FreeBSD.
Wow. Okay.
For tier 1.
For what?
For tier 1.
What is that?
So tier 1 and FreeBSD means the main supported release, not in terms of supporting the code. So basically right now it's MD64 and i386. But it means that the one we are providing binary security patches, well, binary security patches, because security patches we provide for everything. And so that's the most common one. We don't provide for MIPS, for example.
Okay. Well, see, we support the platform or we don't support it. So there is no tier 1, 2, 3 on OpenBSD.
Yeah, so basically on FreeBSD the status right now is on tier 1. We removed GCC, lives under C++, we have a almost full compiler chain BSD license. We also removed half of the BNutil using our home-baked Elfloop chain project, which removes everything but the linker. We are pretty close to add LLD right now, which will be the next linker to replace BNutil totally. And so the only left things we removed TechInfo because who cares? Who reads TechInfo files? I mean, no one. We removed CVS, obviously, because we're not on CVS anymore. We removed RCS. And GDB is slowly being removed, replaced by LLDB. So what is left is we still have GNU-diff. Well, SDiff has been replaced by an OpenBSD and a BSD mix plus some FreeBSD patches on top of it. You might want the patches, by the way.
Send them over.
Yeah, I need to. Graph is still there because a couple of man pages are not rendering, and because we have a lot of papers that were written back in the old time by FreeBSD developers that are in the base system, that are written in RAW. So we are still looking at what we do with that. GNU grep is still there because there is too many bugs in BSD grep for now. But I mean, for FreeBSD 12, I'm pretty sure that will be fully without any GPL license stuff. What is the situation for you?
Well, okay, I will not talk about the licenses itself because I'm not a religious guy. Besides a few exceptions, most of the userland is BSD license on OpenBSD. Obviously still have some kind of a fork of GNU CVS that we cannot remove right now. RCS is actually a rewrite, BSD rewrite implementation. So that's under a BSD license. ManDoc takes care of all our man needs, so we actually don't need a rough in the base system at all. So that's gone since a while. Regarding the tool chain, you guys are figurehead, I agree. But we finally did jump on the bandwagon thanks to the ARM64 architecture. So now we do have LLVM, CLang, and all the gang in base. I don't want to go too much into detail because this effort is somewhat recent. So there's probably a lot of things that are going to change in the upcoming month. But we're going pretty much into the same directions as you guys are, LLD, C++, etc., etc. But as I mentioned earlier, we have no tier 1, 2, 3. So we still have to support some architecture that will most probably never be supported by LLVM and the gang. So we'll have to keep GCC and such in base. Yeah.
Yeah, so I'm pretty sure that it took that long because you wanted to skip one of the subjects, which is this one.
We don't want to talk about that.
Yeah. I think we will have to. I think we'll have to. Well, we'll be very quick. So basically we have a lot of file system support, including very modern one. We have journalization, soft updates, things like that. We have very nice SCSI support, very low-level system for storage, multipass, encryption, whatever. What is the situation on OpenBSD?
I don't think people are really interested. Well, I guess, I will summarize it by saying that we still have bugs in soft updates.
Yeah. You still have bugs in soft updates? Seriously?
Yeah. But, I mean, you guys have Kurt, so.
Yeah, true.
It's easy to do. But yeah, no, we don't have ZFS, obviously. I guess licensing, but not just that. I use ZFS daily on different operating systems, Linux or FreeBSD. It's really great. It's just super scary. What scares me the most is that it requires ECC memory. And when the file system requires ECC memory,
It doesn't really. You can leave
well,
it out.
it's highly recommended. Of course, it works without it, but so that's kind of scary. It's big. It's not just a file system. It's actually an entire volume maintenance, whatever.
Too
But
bad,
I mean, feature-wise, it's great. It's awesome, and there's no.
too bad we don't have time to compare our desktop situation.
Well, actually, pretty much the same on the desktop, I guess.
Yeah, we sucked, I think.
That's
But
not entirely.
it's getting there. It's not entirely true. We have all the packages, everything, but I mean the drivers are we are still lagging behind, and the wireless driver.
Wi-Fi and X.
Yeah.
But anyway, so all things considered, it's pretty obvious that my BSD sucks less than yours.
I'm not really sure. I pretty found that mine sucks very well less than yours. Anyway, I'm really happy that OpenBSD, even if it sucks more than FreeBSD, is around as they push a lot of BSD license tool and they are very pushing also security coding principle and widespreading that. So I'm very happy that you are there, guys.
Thank you. Well, I think FreeBSD is very important as well. First of all, it's a real enterprise operating system. And it's, for me, the way I see it, it's slowly filling up the spot left by Solaris. It bundles some amazing piece of technology. And what is great about it is that it's actually our emblem to the external ecosystem. That is people know about FreeBSD. A huge company uses FreeBSD, Netflix and all. So it's not just like some weird fringe operating system. So
Thank you. So we both organize the next EuroBSDCon in Paris in September. So we hope to see you, everyone there. Save the dates.
and you can have the long version of the talk.
Yeah. So actually, we know now that we could fit 2 hours.
It would be in English.
Well, in Franglish.
Yeah. Anyway, thank you very much.
Thank you.
I was what?
C'était pas mal.